Here we're going to try to estimate the absolute error in approximating S. So let me first explain what I'm saying here. We said this is our alternating series where the Bn part of the series is positive. We said alternating series, if Bn is decreasing, that was our condition, first condition. And the second condition is that limit Bn n infinity approaches to 0, then we say that using alternating series test, the given series converges. Okay. Now, what is this? Converges means that you're somehow able to find this sum. Let's write this sum. This sum means first term, then the second term is negative, plus third term, negative fourth term, and so on. Somewhere we are getting negative 1 the power n minus 1 bn and plus bn plus 1. It keeps on going until infinity, right? So what do we have here? Here we have plus bn plus 1 minus bn plus 2 and so on, right? So you guys notice S, this much part of S is called Sn, right? The whole thing is S. Let's name this remaining part as Rn. So S sum to infinity is equal to Sn plus Rn. So S minus Sn is equal to R, right? Now let's take it in absolute value. We are saying whatever the remaining part is, the error is, that is gonna be in absolute value smaller than this term, Bn plus 1. Why? Because the remaining part is smaller than Bn plus 1. It's being subtracted from Bn plus 1. So in absolute value, this is going to be smaller than Bn plus 1. So absolute error in approximating S is sum to infinity by Sn. If we just subtract until Sn, if we just add the terms until Sn, then the only error will be left would be smaller than Bn plus 1. Okay, so that is the main theorem of estimation. We are going to practice how we actually use this in examples by taking the next example. Let's look at this question. It says determine if the series converges or diverges. I notice that the series have negative 1 the power n minus 1. So this is alternating series. So that means I am able to check with AST. So what is the Bn part of the series? Bn is 1 by n4, right? We have to check two things. Number one, we need to find limit n approaches to infinity of Bn and see if it is 0. That is going to be 1 by n4. And we know that limit is 0, right? Because the denominator is approaching to infinity. 1 by infinity is 0. That is easy. The second part we need to prove is that Bn is decreasing or not. So for that, we know that Bn, we need to prove that Bn plus 1 is less than Bn, right? That's what we need to check. Bn plus 1 is what? 1 by n plus 1 the power 4. And Bn is 1 by n the power 4. We know that n plus 1 is more than n. Therefore, n plus 1 power 4 will be more than n the power 4. So when I reciprocate it, clearly that has to be less than 1 by n the power 4. So therefore, I am through with the second condition also, that Bn is decreasing. So using AST, I can say the given series. Which one is the given series? Negative 1 the power n minus 1 divided by n4 is convergent. Okay, that part is done. Now, the question has another part. It says with absolute error less than 10 the power negative 3. So that means how many terms do we need? This question means how many terms we need to add to get error less than 10 the power negative 3. What was absolute error? Absolute error is Rn. We know that is less than Bn plus 1. Okay, that means absolute error Rn is less than, what is Bn plus 1? 1 by n the power plus 1 the power 4, right? We want Rn to be less than 10 raised to the power negative 3. Therefore, basically, if this is less than 10 the power negative 3, Rn will automatically be less than 10 the power negative 3. So somehow, if we find n large enough such that 1 by n plus 1 power 4 is less than 10 the power negative 3, then Rn clearly will be less than 10 the power negative 3. We want Rn to be less than 10 the power negative 3. That is our goal. Absolute error should be less than that. But we are trying to find, we are good enough if we can just find the nth term, which is less than 10 the power negative 3. How do we do that? To do that, I'm going to actually calculate B1. What was B1? B1 is 1 by 1 the power 4. That is just 1. Then I'm going to calculate 1 by B2, which is 1 by 2 the power 4. I'm going to keep on doing it until I get some term which is less than 10 the power negative 3. What is 10 the power negative 3? It's 0.001, right? 3 decimal places to the left of that. 1 by 1000 is 0.001. So I'm going to use my, say, desmos.com. So you guys notice what I've calculated. B2 is 1 by 24 is 0.0625. B3 is 1 by 3 to the power 4 is 0.0123. B4 is 0.003. And B5 here is 0.0016. And let's calculate this last one. B6 is 0.0007. So we notice that the first time when your term becomes less than 0.001 is at 6, right? So n plus 1 is equal to what? 6. So how many terms are enough to add your absolute value equal to 10 negative 3 is 5. That is n, okay? Because n plus 1 is coming to be 6, n will be equal to 5. That means when you want to calculate the sum such that absolute error is less than 10 the power negative 3, it's enough to add the first 5 terms. The first term is B1, second term is B2, the third term is B3, B4 plus B5. Okay, so we have already calculated these terms. We just need to write them alternatively. Why are we writing alternatively? Remember, our series is alternative, right? So minus 003 plus 0.0016. You add all of these terms and I put it in the calculator and approximately I'm getting 0.947. So that is approximated sum to the error of 10 raised to the power negative 3. So they can ask you multiple questions. They can ask you how many terms we need to add to get error less than 10 raised to the power negative 3. You're going to add answer 5, right? Where did that answer come? We wanted Rn to be less than this. Rn is less than Bn plus 1. So we kept finding Bn plus 1 until we get a number which is less than 0.001. And using that, we got n plus 1 equal to 6. So we only needed to add 5 terms. If they ask find the sum such that approximate error is less than that, then you add the first 5 terms. Basically, remember that the terms are alternative. So when you're adding them, they are plus minus plus minus.